Hello, my name is Duncan Phillips. I am a civil engineering student at the University of Louisville. Today, I'm going to be going over two math problems. I was a Calculus 1 and 2 and Pre-Calculus tutor last semester. This semester, I'm working full-time. So I'm just going to start doing videos to keep up my skills. Today, I'm going to be going over, as I said, two problems. One of them, it's gonna be creating or finding the intersection of two parametric equations. So we're gonna do a system of parametric equations, and the second question is going to be using those two parametric equations and finding the plane created by those two lines. So I'm gonna get started now. Start screen recording 3, 2, 1, and yeah. So problem number 1 reads, find where the lines L1, x equals 1 plus 2t, y equals 2 plus 3t, and z equals 3 plus 4t, and line 2, x equals 2 plus s, y equals 4 plus 2s, and z equals -1 minus 4s intersect. Now, to solve this problem, we're just going to take our x's. So we're going to say x1, so the x equation for line 2 equals x2, y1 equals y2, and y3 and z1, I'm not redoing this because of that, equals z2. And to do that, we're going to do a standard system of equations. Then we're going to plug it in and make sure that everything's okay. So in reality, we have two unknowns. Our two unknowns are t and s. We don't know what t and s are. So to find out what t and s are, we're going to take two of our equations and we're going to eliminate one of the variables and solve for the other as follows. So I'm going to start with the x and z equations. So x1 equals 1 plus 2t equals x2, which is the x equation of line 2, and that's 2 plus s. So from there, we're going to take our z equations, 3 plus 2, 4t, reading is hard, and z equals -1 minus 4s. So the reason why I chose these equations is that because I can multiply this top equation by 4, and I can get 4 plus 8t equals 8 plus 4s. I was getting ahead of myself with the minus 4s because this is the same thing. It's going to be 3 plus 4t equals -1 minus 4s. And if I add these two equations together, then that results in 7 plus 12t equals 7 minus 0s. 4 minus 4, that's 0. So if we solve further for t by subtracting 7 from both sides, we're left with 12t equals 0, therefore t equals 0. Now that we have t, we can easily solve for s. I'm just going to use the y equation because we haven't used that. So 2 plus 3t equals 4 plus 2s. So we know what t is, so therefore 2 equals 4 plus 2s. So -2, if you subtract 4 from both sides of the equation, equals 2s. So 2s equals, so s is going to be equal to -1. So those are our values for t and s. Now we can plug in t into the equations for line 1 and s into the equations for line 2. And when we do that, we should have a common point. So x equals 1 plus 2t equals 1 plus 0 equals 1. Y equals 2 plus 3 times 0, it's just 2. And z equals 3. So that gives us the point 1, 2, 3. Then for line 2, and I'll write L1 up here, we'll have x equals 2 minus 1 equals 1, y equals 4 minus 2 equals 2, and z equals negative 1 minus 4 times negative 1, so that's going to be plus 4 equals 3, which also gives us the point 1, 2, 3. Therefore, there's going to be a point of intersection at 1, 2, 3, x, y, z. That's the coordinate system. And that's our answer. Sorry, my handwriting's not really neat at that end, but we'll ball. So, as I said before, problem 2 is find the equation of the plane determined by those lines from problem 1. So, line 1 equals, or is, defined by the parametric equation x equals 1 plus 2t, I think, and then y equals 2 plus 3t, and z equals 3 plus something, 3 plus 4t. And then line 2 is given by the equations x equals 2 plus s, yes. Y equals 4 plus 2s. What doesn't it like? And z equals negative 1 minus 4s. So to find the equation of the plane, I'm going to create vectors for each of these, or for these two lines, I should say. I'm going to turn them into vectors, and then I'm going to do the vector cross product so I can find the normal vector. And that will give us, that normal vector is going to be perpendicular to the plane created by those two lines. Boom, 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 boom. And we use that normal vector to define present tense, the equation of the plane. Let's get started. Our vector 1 will be equal to 2i plus 3j plus, I wrote down that equation wrong, 3 plus 4t. Why didn't you guys tell me? Just kidding, no one's watching this. 4k. Vector 2 is going to equal I plus 2j minus 4k. So the reason for that is these coefficients, if you haven't picked it up. To make a parametric equation into a vector, for your x component, you take the coefficient of the parameter, so t, and you multiply that by the unit vector in the x direction. So that's I. Unit vector in x is I, and y it's j, and in z the unit vector is k. So now we want to find the normal vector. To do that, we're going to create a little matrix determinant type beat, and we're going to have I, j, and k. These are the unit vectors again. And then we're going to have the First vector, 2i plus 3j plus 4k. And vector 2, 1, 2, and negative 4. So then that's going to be equal to this. So we take, if we have this, then we're going to multiply these two and multiply these two, and you're going to subtract the second cross from the first. And we're going to repeat that with j and k, where we isolate the column. Or basically, if we're doing j, we don't use these two numbers. There's a reason for that. I forgot it. So I is going to be negative 12 minus 4 times 2 is 8 plus j minus j. It's a negative. The second one is a negative. Minus j times negative 8 minus 4 plus k times 2 times 2 is 4 minus 3. This implies that our normal vector is going to be equal to negative 20i plus 12j plus k. So once we have our normal vector, we want to find our plane. To do that, we're going to take our coefficients in the x, y, and z direction, and we're going to say negative 20, that's our coefficient, times x minus, we want to give this a sort of common point with both of our vectors so we know it's on the plane. So what's a point that we know is on, is like in this area, in this plane of existence, this plane in 3D space? That's right, that intersection right there. And we found that last problem, that point of intersection is 1, 2, 3. So to define our plane fully, we are going to have our coefficient of our normal vector in the x direction in this example. So negative 20 times the quantity x minus this x value from this point of intersection. So x minus 1. And then plus 12 times y minus 2 plus 1, because it's just 1k, times z minus 3 equals 0. And then that is our plane. So to simplify this, we'll just distribute. So we'll have negative 20 plus 12 minus 24, that's how you do math, plus z minus 3 equals 0. So then that's going to be negative 20x. Keep making silly mistakes. Therefore, that's why you look back at your work, by the way. Therefore, negative 20x, that should be a y too. And then that's silly. Negative 20x plus 12y plus z. And then these constants, they're going to simplify down to minus 7 equals 0. So our plane is defined by the equation negative 20x plus 12y plus z equals 7. And those are just some examples on low power mode. But those are just some examples on systems of parametric equations, turning parametric equations into vectors, and using those vectors to do the vector cross product. So you can find a normal vector to the plane created by those two vectors, which I think that's a very good introduction to three-dimensional mathematics. U of L does it in Calc 2. That's all I gotta say.